Now let's see what is the use of this potentiometer. So there is one way to use the potentiometer is to compare the two different EMFs. Okay, so this is the first diagram to check how to compare the two different EMFs. So here is the battery, there is key, and this is the rheostat. We are going to attach the two different batteries in between which we have to compare the EMF. So epsilon 1 is first EMF, epsilon 2 is second EMF. In both cases, the positive side is attached to A, which is the higher potential side. So here this is positive side. So we are attaching positive side to the positive side. Negative terminal of these batteries are connected to galvanometer and jockey through the keys. So if this one key is on, so the current is flowing through this circuit. In that case, I am getting some null point. Using this galvanometer, we can find out the null point, and that length, let's say that length is equal to L1. So the voltage in between that length will be equal to capital K into L, because we have seen earlier that capital K is the constant of this potentiometer. So the voltage of first case, or we can just write this as epsilon 1 is equal to K into L1. Okay, I will write here, it is epsilon 1. And for the second case, similarly, we can get epsilon 2 is equal to K into L2. This is the second case. So what is mean by a comparison? So we will take ratios of this, and what we will get is epsilon 1 divided by epsilon 2, and now we can see that K and K are constants, so they will cancel with each other. So this will become equal to L1 divided by L2. So this will become L1 divided by L2. Now what does this mean? So if the E1 gives L1, that is null deflection point, and the length, suppose this is point C, or let's say point C1. So for first case, I am attaching this case, and in this case I am getting this length L1. So I am getting the length L1 to get this null point. Then the potential of this E1 will be equal to K into L1, or proportional to L1. And for the second case, if I attach this length, and suppose here is point C2, and the length will be L2 right here, that is length is L2. Then in that case, I will get the EMF is equal to, or potential difference is equal to K into L2. So taking the ratios of these two, we will get epsilon 1 divided by epsilon 2 is equal to L1 divided by L2. So this is the application of potentiometer, that we can compare the EMFs of two EMF using the just measuring the length. So I have to just measure the L1 and L2 and take the ratio of this. Now this is the another method to compare two EMFs. So what we will do in this case, instead of attaching the EMFs parallel, what we will do is we will check this, we will attach this in series in two ways. In first case, we will attach the negative side of first to the positive side of another, and in another case we will attach negative side to the negative side, or positive side to positive side, but in that case also E1 must be greater than E2. So now what we will get, using the same principle, in first case epsilon 1 plus epsilon 2, and let's say this time I got the length L1, that is the length up to null point. And for the next case I will get epsilon 1 minus epsilon 2, and in that case I get length L2. So I'm measuring the length in same kind of circuit, but instead of two parallel circuits I will get one series circuit, and I'm measuring this length L1 and L2 as the when the null deflection is shown by the galvanometer. In previous case, as we have taken the ratio, we will take the ratio of these two, and we will get epsilon 1 plus epsilon 2 divided by epsilon minus epsilon 2 is equal to L1 divided by L2. So I will get this ratio. Now there is property in mathematics, dividendo and componendo, or componendo and dividendo method. So if we use that, we can convert this formula into epsilon 1 divided by epsilon 2, and that will be equal to, so in that case check whether positive, where is the positive and where is the negative. So positive on the numerator, negative on the denominator. So we will do this same on the RHS. So we will get L1 plus L2 in the numerator and divided by L1 minus L2. So just check the lengths and then take the sum and difference and take the ratio of this. So we will get the comparison or the ratio of two given potential differences or EMFs. So in this way, either using sum and difference method, we can find out the comparison. We can compare two EMFs, or as we have seen earlier, using the compare by parallel method. So we are using here in parallel manner, we are attaching the EMFs, and in this method we are attaching in series. So this is just the first application of potentiometer. In the next video we will see few more applications of potentiometer. Thank you.